one, so that's okay. This is the x-intercept for the black line. Right, so I just need, when does this thing equal 0? Right, add 2, take the square root. If I take the square root though, that also tells me this one is positive root 2. 0. Cool, cool. Okay, we've got y and x-intercepts for the black, yes. For the red, we've got x-intercept.
Could this be 0 and negative root 2?
Yeah,
And then 0 and
Right,
positive
how do you
2?
know, TJ?
I
You just looked at it, okay. Can we, what exactly did you look at?
You're
doing good,
because it's x squared minus 2, I just picture y squared minus 2 and it'll give me the same answer.
because they're inverses.
Because basically, because I just picture the x and y as the
So you're looking at this thing, and then just going, oh, it has to flip to there. So this has to be the same as that, just with the x and y flipped.
Yeah.
Is that what you're saying? Oh,
Yeah.
I wrote that around the wrong way.
Yeah.
Ooh, I wrote that around the wrong way as well. Good job.
We should do an ASMR challenge on this camera.
They all around the wrong way. Yes. Beautiful. So yeah, that's the good part. You only need to figure out some of these things once, and then you've got freebies for the others. Well, that's good. Well, now we've got tricky bits. We've got this guy, and then we've got the painful ones last.
Just a negative 1 and 2.
There. Alright, so we're going to do this all deliberately the painful way, so that you can appreciate the good way.
No, it's not.
Okay, so I want to get all the purple and blue dots. How do I get them? Right, make the two functions equal each other, yeah? Alright, so I've got x squared minus 2 has to equal the other guy, which is
Net root x plus 2.
plus minus root
X plus 2.
x plus 2. Well, that's already looking a bit chunky.
Can we square it?
Right, we're going to have to square everything to get rid of that square root. So I'm going to square all of this. Conveniently, if I square plus minus, what do I get? If you square a positive, you get a plus. If you square a negative, you get plus. So they're going to take care of themselves straight away. So that's a massive win. Brilliant. All right.
Minus 2?
I'm going to want to expand this out.
Yeah.
Yes.
X to the 4 minus 4x squared plus 4 equals x plus 2. Go. Minus stuff across. Plus 2 over. Cool. At this stage you've got a couple of options.
Would we want to... Would we...
You remember how I said like grouping will almost never come up?
Oh,
This is one of the times where you can do a bit of grouping.
Yo, and just go,
so is it x
you can
cubed?
go x cubed, x squared, brackets, 1 minus,
He's like, no, this is taking too long.
So I can do that, right? And then I can go, oh, look at that. That looks interesting. What can I do with this?
difference of perfect squares.
Difference two squares, right? Difference perfect squares, difference of 2 squares. Plus 2
X minus
minus 2. Then I look at this and go, oh, that's interesting. This is going to be some version of this. But what I want, I'm going to put a plus here deliberately. Sorry, a minus. A minus here deliberately and do
x minus 2.
that.
X minus 2 what?
Because now I've got a match.
Shouldn't it be plus 2?
That is...
If I expand this, I'll get back.
Oh,
So,
sorry.
It's negative times the whole thing.
Cool.
My bad.
So now I can go, cool, these things are in common.
Yeah, so it'll be x minus 2, and then another
Right,
bracket
so
x plus
this
2.
is now in common to everything, times this with this minus one of those. Cool. Brilliant. Do we have a solution?
No.
At least one solution.
Yes.
Yes, what is it?
Plus
Positive 2.
2, right? That gave us a solution. Brilliant. Crap.
Yes.
Carry on. So this is always just going to be sitting there. It's not. We don't want it to change though. We're just going to leave him sitting pretty. Cool. We'll expand this out. Because otherwise you're going to be in a lot of pain if you try to do it any other way.
How did you expand it? Oh, yeah.
Just this bit from this expanding. Cool. Alright. Do we have any cool tricks for factorising cubics?
Throwing numbers at it
Throw numbers at it to do what?
to find a factor.
And then,
Divide.
right, polynomial.
A long division.
You could have done polynomial long division from here,
Yes, that's what I was going to say.
right? That's totally fine. How long does it take to do polynomial long division?
A pretty long time.
Bit of time. 1, 2, 3. I've already got one for free.
Yes.
So when you can find other ways, great. Is it necessary to do grouping? No. You could have done polynomial long division from there. Right? Great. All right. What can you throw into that to make it go to 0?
What would be +2?
To this bit. What, sorry, what did you say?
Oh, -2.
-2.
That's my
Oh
final.
yeah, sorry, yeah.
-2. Oh, okay, never mind.
-2, that turns into -8. -2, this turns into +8, and then -1.
Ah, damn
So
it.
end up as-
Good
yeah,
one,
it's one starts here.
Damn it. Damn it.
Go simple numbers.
1, -1.
Yeah.
1 plus 2 times 1 minus 1.
Is it -1?
Yeah.
Right, negative 1, -1,
Oh, sorry.
positive 2, -1, yeah, that goes to 0. So -1 works for that. So what are we actually dividing by?
+1.
X plus 1, so you got x plus 1.
Oh, sorry, x +1.
X cubed plus 2x squared minus.
That,
And then there's
and it'll save you a bit of time. So I've still got this guy. Then I'm going to have this guy. And then I'm going to have something else.
Is that, will that be your point? That'll be your, oh yeah, that will be your point, eh? So it'll be like x squared.
Sorry, x squared plus x minus 1.
Have you already done this?
Who? Not me. I don't know.
Cool, so we end up with that. Great. We're almost there. Now we just have to deal with this. Is that going to factorise?
Not nicely.
Doesn't look like it. How could you convince yourself?
You could throw numbers at it. Prove that it doesn't work.
Right, two things that times the -1 and add to 1.
1 -1. Oh, gee. No.
Right, that goes to 0, yeah? So this is if there is a solution, it's not going to be a nice rational thing. Okay, so how can I factorise it then?
Quadratic formula.
Okay, you could do quadratic formula since all we're interested in is the solutions. You could do that. Right, alternately, you could complete a square.
Okay.
Alright, I'm going to complete a square for the sake of doing everything. So we get x plus a half squared. That gives me a quarter. I need this, so minus 5 on 4. So we get x minus 2,
Oh,
x
so
plus
I write the
1,
until we come to
x,
the polynomial, the long division. I was like, yeah,
square roots of this, so we get plus 1 plus root 5 on 2, and x plus 1 minus
-root 5 on 2.
2. Equals 0.
Yes, lovely.
Right, you're probably not going to guess those.
So I have a question. So are those 4 points all the 4 points that we need to find out?
Right, so the nice ones, actually, let's just write x equals. So x equals, that's nice, 2. That's nice, -1. Less nice, but we can still do it. -1 minus root 5 on 2. Minus 1 plus root 5.
He just read them wrong.
So those are all our x values for all.
No, sorry, you didn't.
Wait, why did you get -1 minus root 5 instead of just -1 plus root 5? Oh,
This
never mind.
one.
Yeah.
So what do I need to put in for x to make this bracket equal 0?
Oh, check, never mind.
Yeah, all good. It's okay. It's a normal thing. Like plus minus stuff always goes haywire in human. Cool. Great. All right.
My weakness.
So let's figure out what the corresponding y values are. Okay, I put in 2. What do I get back?
2.
2. That's nice. Right. I'm just chucking it into the first. Oh, by the way, would you rather throw it into the first rule or the square root rules?
The first one.
The first one.
Right.
Because you get 2
Brilliant.
answers.
Chuck in -1. What do you get?
-3.
Negative
No, it's -1.
-1.
1. Well, that's interesting. All right. Let's mark those off before we do anything else.
Yes, thank you so much.
This is it. Oh, wait.
That's 2, 2.
2, 2? Yep, there it is.
And then -1, -1.
Oh, wait, before you do it,
Oh, but he did.
What? So, what's up?
you can you just work it from there and just flip it around so it'll be -2, -2. Oh, wait, no, tricks, never mind.
Okay.
Never mind.
Okay. No, you were having good thinking. You were trying to exploit the symmetry. So that's good.
Yeah.
That's what I want you to be trying to do. Always try to exploit whatever you know is true. But as you correctly reasoned, that's not going to work for this.
Yeah.
Are we surprised that this is 2, 2 and this is -1, -1?
No.
Why not?
Oh, just because.
So what I mean by that, are we surprised that they're the same number?
No, because they're
No.
symmetrical.
Because it's symmetrical?
Because they're on the x, y line.
Right, this line is y equals x.
Oh yeah.
So if I know the x coordinate, I know the y coordinate, it's the same thing.
Ah.
Right, so I didn't even need to put them back in that, because I would have known, oh, it has to be on that. Having said that, I didn't necessarily know which one was which, so there's that. Cool, alright, now we've got this thing. That's
No,
gonna
but
be
you would have.
plain.
You would have known which one was which because one was a positive, one was a negative.
That's positive, that's negative.
But if you get y equals x and you get a 2, then it's going to be 2, 2. If you're,
Yeah, okay, but then you've had to sub it in order to verify it. Yeah? No.
But why don't you just sub it into the y equals x?
Yeah, okay, so there's 4 solutions, yeah?
Yes.
Without knowing what those are, if I said one of the solutions is x is 2, can you, if I didn't have a scale on this, could you tell if it was that one or that one?
If you didn't have a scale,
If I didn't have the scale.
well, I would make an assumption that it was top right because
Okay,
it's positive.
But this x is positive here. And all I solved was
But
x is 2.
But if x is positive 2, then y would be positive 2 because y equals x.
Only if I'm talking about that one. What if this one was positive 2? This one might have been positive 6 or something.
Oh,
Maybe
yeah,
6, 6.
yeah, I get it. Yeah, because it's something.
Right? You can figure it out because we know the x-intercept's root 2. And 2 is bigger than root 2. So that is how you could do it. But, yeah. Beautiful. Alright. Last bit. So these are purple boys. Then these guys are the orange boys. -1 plus root 5 on 2. Where's the other one over here? -1 minus root 5 on 2. Now. Cool, alright. We could sub these into that. Right, which we're going to start. So I've got this whole thing squared, -1 minus root 5 on 2
Minus 2.
squared minus 2. Are you looking forward to doing that?
No.
No, right? We could do it. Right? Can we outsmart the question?
Yeah.
How are you going to do it?
I don't know.
Just write that in and then the y.
Say again. Look at the picture. Look at the 2 blue dots. There's a symmetry, so
Which is the bigger one?
You need to switch x, y, because.
right, they're just the switched x, y values of each other. So this must be this thing's y,
Oh, lol.
Oh!
and this must be this thing's y. Now you're welcome to do this pain in the ass calculation, or you go, hang on, is there a smarter way of getting around this? Right, great. And now we don't even have to check because it makes perfect sense. Fantastic. So unless we start up here, which is always an option, we're pretty happy about that. Right, now, these blue dots, generally speaking, I'm not going to get you to find. Right, most of the time I'm only going to get you to find the ones that lie on the line y equals x. 2 seconds.
Yep.
Most of the time I'm only going to get you to find those ones. Having said that, in theory, you should be able to find the blue dot ones. To find these ones, the best thing about that is you don't even have to make this equal this, because if we're on the purple line, we can just say x squared minus 2 equals x, because it has to be on that line. So instead of getting this whole square root thing, squaring it, getting up to a power of 4, well, this is now this. That's convenient. 2 things at times to -2 and add to -1.
1 and 2. -1 and 2.
-1 and 2, -2 and 1, hopefully. Great, therefore x is 2 or -1. Hey, we saved a lot of time.
Oh my gosh.
Right, so this is why you want to be looking for shortcuts where they exist, right?
But so,
Having some-
I think there's.
how do we know that reflection of the line is that reflection of the line?
How do we know that reflection of the line? I'm not sure, you just said a circular thing.
So like let's say that line of reflection wasn't there. How would we know that to draw it? Like do we have to draw that line?
The purple one?
Yeah.
You don't have to draw it at all if you don't want.
No, like will it show up on the will we draw that line or will the line be already there? Because if so,
No,
like
you draw it.
so
So I would give you the black, right, just this bit, and say, find me the inverse, and mark off all interesting points.
but how would you know? Would you always have to draw the line in between those intersection points?
The purple dotted.
Yeah.
You don't have to draw it, but it helps so that you can look at it and go, is this flipping over correctly?
Yeah.
So it's just a helpful guide. You don't need it. Right? But it also helps to remind you that, oh, these, where they intersect on this, they should be the same number. Yep.
If the test did ask for interesting points,
Yep.
would you have to label all four of them points, including the?
In theory, yes.
Okay.
Right, and that's going to be worth like all of 1 or 2 points on the next attack, because it's going to happen once.
And why will always equal
Very
x
last question, purely so that the people that are like kicking ass all throughout the whole thing, they can actually give them a mild challenge towards it. Yep. What'd you say, TJ?
Purple will always equal y equals xe.
Yep.
Oh, and then from that x equals 2 and -1, how would you get -1 minus root 5 over 2?
You don't. So this that's why I'm writing it in purple. It only holds for the intersections that are along the purple line.
And then you'll just have to use
Right, to get these guys, you have to go through the blue.
okay.
Hence why it's only worth 1 or 2 marks at the absolute end of the next stack, just purely as a challenge thing. Yep.
By the way, how did you actually get to the purple equation? I don't think I was paying attention.
This guy.
Yeah.
So I just picked either of the 2 functions and said, okay, when does this function intersect with the purple line? Well, the purple line is y equals x.
Okay.
So just when does one of them equal x? So that's there and then. Yep, back.
So that would work through all of them.
That'll work through everything. It'll always find the intersections that lie on the line y equals x for inverses.
Yeah, but how did you know plus or minus
Sorry.
square root of x plus 2 is on that line?
Plus or minus.
X plus 2. Root x plus 2.
What?
So aren't you using the inverse of x squared minus 2?
No,
Oh.
I'm not following.
Well,
what
wait.
you're saying, sorry.
No. So you didn't use x squared minus 2 equals square root plus or minus square root x plus 2. You didn't use that either.
I only use that for the blue.
Oh, okay, so what you used to find that out is that you know that the points are on the reflection line.
Yeah,
So
if
you
I
just-
know the points are on the reflection line,
Oh,
I
so
can
you
shortcut it
just
to this.
oh,
Yes.
okay.
Yeah,
okay.
this is a shortcut.
Yeah.
Yeah,
Okay.
but it only gives you those ones. It won't give you ones that are on the line.
Yo.
Perfect, yeah.
So if we subbed in 4x for the other equation,
When you say the other...
sorry,
this one?
the second one we did,
This one.
4x equals
Yep.
x,
Yep.
we would get 0.
Yeah, 4x equals x. What's the only solution? 0. That'll work this way.
Yeah, okay, cool.
And you can do it with this, x plus 3 equals x. What does x equal? No solution.
Yeah, okay.
So there's no...
Could you do the same point for that?
The same thing with this, x squared equals x. That's x squared minus x, so that's
X.
x minus 1, so 0 and 1. So yeah, for nice simple things it will work. It's only for the complicated ones where you've got extra intersections off the
Yeah.
y equals x line that it won't work. Or at least it won't work completely. It won't give you all of the things. Cool. Everyone's happy?
Yes.
Yep. I know that's quite a long thing, but if I give you the full picture and then do exactly that at the end, then you're like, okay, I can follow this, and then I give you the shortcut, and you're like, ooh, that's a good shortcut, and so you're more likely to remember the shortcut. Cool, that's 5G, and that's it.
Hey. Very good.
The next one was.
Like this, like that, you It's all of the modelling application stuff.
Oh.
So that won't be on the stack.
But you
per
know,
se,
have you
but it forces you to practice the stuff that we use
Witch's Forest? Where Asta goes to the Witch's Forest? Yeah, that's the part. That's the start of it.
Oh, when he goes to the forest. Oh.
The Witch's Forest.
Did you guys tip that around? Okay.